Power plant based on nuclear energy. In the power plant based on nuclear energy, steam turbine is used. However, the energy released by the fission of nuclei of atom like uranium is used. That means no fuel is burnt in this process, but nuclear fission reaction is used to produce heat. Either uranium or plutonium is used to produce steam at high temperature and high pressure. Energy in the steam, that is the kinetic energy in the steam, rotates the turbine, which in turn drives the generator, and then the electricity is produced. So if you want to see the flow chart of a nuclear power plant, we have nuclear reactor for nuclear fission. Then heat is produced in nuclear fission, which is used by the system for steam generation from water. Steam drives the steam turbine drives the generator, and ultimately electric energy is produced. Then there is a system for conversion of steam into water. Here fuel, coal is not used, instead uranium or plutonium is used as a fuel. Thus here nuclear energy is converted into thermal energy. So first we have nuclear energy. Nuclear energy is converted into thermal energy. Then thermal energy is converted into kinetic energy of steam. And then kinetic energy of steam is converted into kinetic energy of the turbine, and ultimately kinetic energy of the turbine is converted into electric energy. So first we have nuclear energy as shown in this flow chart, which is converted into thermal energy, which is used to produce kinetic energy in the steam that drives the turbine, that is the kinetic energy of the turbine, and ultimately we get the electric energy. So if coal is not burnt in this process, how heat energy is produced? Heat energy is produced by the fission of uranium nucleus. Uranium-235 is a stable isotope. 235 is the mass number, that means it is the addition of the protons and neutrons in that uranium. It absorbs the neutron and converts to its isotope uranium-236. So when uranium-235 atom, it absorbs one neutron, its mass number increases by 1, and then uranium-235 becomes uranium-236. Uranium-236 being extremely unstable, it undergoes nuclear fission and it produces two smaller nuclei of barium and krypton, and in the process 3 neutrons are also released, and large amount of energy, 200 mega electron volt energy is released by the fission of one uranium atom. The 3 neutrons which are produced in this reaction, they continue this process of fission. So one fission, it creates 3 electron and hence is responsible for 3 more fissions. So those 3 fissions will again do 9 more fission, then 27, and like that the chain reaction will continue. The neutron release in the reaction, it releases more energy through fission of more uranium nuclei. So this is a chain reaction. It continues on its own. In the nuclear power plant, a controlled chain reaction is result. So there are some controllers which absorb neutrons and decrease their kinetic energy so that this reaction is not uncontrollable. In a nuclear bomb, the uncontrolled reaction takes place and very large amount of heat is produced. In the nuclear power plant, the reaction is controlled and that's why it's a stable system. Nuclear power plants are there in Kudakulam, then Tarapur, Rawatbhata and Kaiga in India. Schematic of the nuclear power plant is as follows. Now you can see that one tower is missing here because there is no combustion of fuel involved in this. So tower for releasing the gases and smoke is not there. Instead, there is a nuclear reactor. In this nuclear reactor, you can see the control pods which absorb excess neutron and they control on their number. So the nuclear reaction is not uncontrollable. Then the heat produced in the nuclear reaction is used to boil water. There is a boiler there. After the boiler, we have turbine in which the kinetic energy is given to the turbine which rotates its blades. It is connected to a generator. So when generator is driven by the turbine, it produces electric energy. Then the steam is given to the cooling tower which condenses it back into water, and then that water is again given to the nuclear reactor. You can see only one tower of here which will release the water vapor and hot gases, but there is no tower for the release of smoke and gases because there is no combustion involved in this type of power generation. A nuclear power plant does not use fossil fuel like coal, therefore problems like air pollution do not arise. Also, if sufficient nuclear fuel is available, it can be a very good source of electric energy. However, there are some problems associated with nuclear power, and that is the product after the fission of the nuclear fuel are also radioactive and they are harmful. These products are called nuclear waste, so it is very difficult to manage a nuclear waste. Accident in the nuclear power plant can be very fatal. This is because the accident may result in the release of harmful radiations. So these are the problems involved with nuclear power plant.